This standard is ARCH.8.EE.A.4.8.1c. The learning target is I can express very large and very small quantities using scientific notation. Let's start with an example. Example 1. In 2018, there were 2.5 times 10 to the third people living in Cave City. In 2019, there were 1.6 times 10 to the fourth living in Cave City. Are there more or less people in Cave City in 2019? So to solve, first work out the scientific notation. 2.5 times 10 to the third is actually, if you write 2.5, then you see that 10 to the third, since we work on the decimal system, is that you're moving 3 digits to the right of this number. So count 1, 2, 3. So that number is 2,500. This number looks like this. 1.6 times 10 to the fourth is 1.6, and then you're going to count 4 spaces over, and you're going to place zeros there as placeholders. So that equals 16,000. So actually, in 2019, 16,000 minus the population in 2018 equals 13,500 more people in 2019. Now, remember, when using scientific notation, there is a decimal point after the first digit, as long as it's not 0. Next, you multiply by 10 to a power, or you divide by 10 to a power. Power meaning exponent. So 50 would be 5 times 10 to the first. Because you made the number look smaller, you have to give it a power so that you know it's actually bigger than 5. The number 500, you move the decimal place to the left 2, and you have the number 5 times 10 squared, or to the second power, because the number isn't 5, it's 500. In this case, number 82, you move the decimal point back 1, so there's a decimal point after the first digit always, and you're going to multiply by 10 to the first. Because you made the number smaller than it was, you have to give it a power equal to the number of decimal places that you move. 976 equals 9.76 times 10 squared. You moved the decimal point back 2 places and made it smaller, so you have to give it a power of 10 to the power of 2. A small number, on the other hand, 0.72, still needs a decimal after the first digit, non-zero. So now you're going to move it to the right, the decimal point. But since you made the number look larger than it actually is, you have to say it's a -1 as an exponent. Here's another one, 0.635. You're going to move it 1 place to the right, and you're going to have 6.35 times 10 to the -1, because you moved it 1 place. And the last one, 0.0004. We're going to have to move the decimal point 1, 2, 3, 4 places until it gets to where you have a decimal after the first number. And since we moved it to the right, the decimal point, we made it look like a larger number than it is. It's actually 4 places smaller. So 4 times 10 to the -4th is the solution. And that completes this lesson.